All right, let's get right into it. Welcome to another explainer. Today, we're cracking open the Grade 7 Science Part 2 textbook and really breaking down its core concepts. We're going on a curiosity-driven journey that's going to take us all the way from the everyday phenomena happening right in your own living room to the massive forces shaping our physical world. If you love figuring out how things work, you are absolutely going to love the way this material is structured.
Okay, let's dive into this. Here's a quick look at our roadmap for today. First, a Grade 7 science overview. Then, we'll look at the world of sound. After that, measuring body temperature, followed by how heat travels fast. And finally, exploring our physical world.
Starting things off with Section 1, Grade 7 Science Overview. So the sheer scale of what we're dealing with here is pretty massive. We aren't just stuck in one narrow field, we're actually connecting entirely different scientific disciplines. Like in Chapter 12, we look at biological processes, the complex systems of life. But then we zoom way out in Chapter 13 to study the atmosphere. And then, boom, right back down into the dirt with Chapter 15 to understand soil composition and erosion. It even tackles force and motion in Chapter 16, and of course, the absolutely crucial global topic of sources of energy in Chapter 19. It's basically a complete toolkit for figuring out exactly how our world operates.
Moving right along to Section 2, the world of sound.
Now, Chapter 11 dives straight into the production and propagation of sound. And it doesn't just ask what sound is in some abstract philosophical way. No, it wants us to really grasp the mechanics, like how is it physically created, and what does propagation actually mean? Well, it's all about understanding exactly how those invisible sound waves travel through the air around us to finally hit our eardrums.
I love how the text prompts us to look at our immediate environment to really ground these concepts. So let me ask you, what sounds did you actually hear today? Maybe it was a bird singing outside your window this morning, or just the background hum of the TV or radio. These aren't just random noises happening by magic. They are physical waves produced by real vibrations and propagated through the air. Taking abstract physics and grounding it in your relatable, everyday reality, that is exactly what makes this explainer, and honestly this science, so incredibly accessible.
Next up, Section 3, Measuring Body Temperature. This brings us to Chapter 14, where we transition into the fascinating rules of heat and temperature. We're stepping away from the mechanical waves of sound and right into the realm of thermal energy and thermodynamics. And it kicks off with something literally every single one of us has dealt with, checking to see if we have a fever. Now, to really understand a fever, you need a baseline, right? And that's exactly what we get here. 36.9 degrees Celsius. This is the standard, healthy body temperature for a human being. It's this rock-solid, factual takeaway that anchors all the subsequent lessons on thermal energy. Because if you know this specific baseline, you instantly know when the thermal equilibrium of the human body is out of whack. And honestly, that is the very foundation of medical diagnostics. And this brilliantly highlights a totally essential scientific skill, understanding and comparing different units of measurement. We learn that 36.9 degrees Celsius is exactly the same as 98.4 degrees Fahrenheit. Depending on what kind of thermometer you're holding or just where you happen to live in the world, knowing both of these scales for a healthy body is an absolute must for accurate scientific observation and data recording. But to really make this information stick, you can't just passively read numbers. You have to become an active, practicing scientist. So we get these cool real-world missions. Step 1, found in Assignment 14.5, tasks the learner with physically measuring and recording the body temperatures of their own family and friends. Then, Step 2, under Assignment 14.6, has them digging up info on modern measuring equipment. It points out that new, more accurate types of thermometers are constantly being invented. I just love this hands-on approach. It directly connects textbook theory to the medicine cabinet in your own bathroom. All right, moving to Section 4, How Heat Travels Fast. Here, heat is clearly defined as a very specific type of energy. And more importantly, we pinpoint the ultimate monumental source of that energy for our entire planet. Yep, the sun. It serves as our absolute largest heat source. Literally everything, from the warmth on your skin on a summer day to the massive energy driving our global weather systems, it all traces back to this giant, fiery star at the center of our solar system. There's actually a specific quote in the text that I think captures the absolute awe of this process beautifully. It says, "Though the sun is some millions of kilometers away from the Earth, we get solar heat very soon." I mean, really pause and think about that for a second. Millions of kilometers of completely empty, freezing vacuum space. Yet this thermal energy bridges that massive gap incredibly fast to warm our planet. It frames heat transfer and solar radiation in a way that just makes you genuinely appreciate the sheer speed, scale, and power of solar energy. And finally, Section 5, Exploring Our Physical World. The back half of this material is just so incredibly diverse, really showing how science touches literally every aspect of our existence. Like we've got Chapter 16 covering force and motion, digging into distance, displacement, and the actual physical forces that move objects. But then, right next to it, in Chapter 17, we completely switch gears. We look inward at nutrients in food, learning how to scientifically identify the very elements that fuel our biological processes. It is such a fantastic, balanced pairing of external physical science and internal biological necessity. And the adventure definitely doesn't stop there. The final chapters promise some incredible deep dives into both the ground beneath our feet and the future of our society. We get into Earth's geology by exploring minerals and rocks, and we unpack the incredibly slow yet insanely powerful process of rock weathering and geological cycles. Then, bringing it all perfectly back to the modern day, the final chapter tackles our most pressing global challenges. We're talking renewable and non-renewable energy sources and figuring out how we can actually achieve sustainable energy usage. It's just highly relevant, absolutely crucial information for understanding the world today. You know, the interlocking gears of science are always turning, and it's a perfect metaphor for how all of these seemingly separate concepts actually fit together. Think about it. The solar heat we just talked about, that drives the atmosphere and weather, which in turn drives rock weathering and soil creation, which then grows the food containing the nutrients we need to get the biological energy to move and apply force. The gears of science are literally always turning, and every single chapter connects to the next in this beautiful, totally logical flow. So after seeing this incredible roadmap, from the propagation of sound waves in your living room to measuring human health, all the way to the millions of kilometers that solar heat travels just to reach us, the only question left is, what scientific mystery are you going to uncover next? This material is clearly packed with answers, just waiting for a curious, focused mind to turn the page. I really hope this look at the source material gave you a solid foundation. Thanks so much for joining me on this explainer. Keep asking questions and definitely keep exploring.